Welcome back to BAS 120. We're going to talk about Chapter 7 today. What do we do with all these statistics? How do we make inferences, conclusions, and all of that? So to the left here we have a bell-shaped curve or a distribution. And if we took a sample, now if we flipped a coin 100 times, I think most of us would agree it would be unlikely that we would often get exactly 50 heads and 50 tails. But if we got something in here, let's say 48 heads and 52 tails, I think most of us would conclude that that wasn't very unlikely, and it wouldn't cause us to conclude that the dice was, or not the dice, the coin was loaded, or the coin was not a fair coin. You know, we flipped it 100 times, we got 48 heads, 50 tails, we'd expect about 52 tails, we'd expect about 50-50. I think most of us would conclude that's okay. Now, to the other sort of way of thinking, if I flipped a coin 100 times and we assumed it was a fair coin, and I got 99 heads and 101 tail, I think some of us would begin to start to question, maybe that coin is not a fair coin, particularly if we were betting some money on it. Let's say the friend always bet heads and beat us 99 out of 100 times. I think we would begin to say it's much more likely that the person I'm dealing with has a weighted or an unfair coin than it is the probability that he or she would flip it 100 times and get only one head. Now, probability tells us there is a probability of flipping a fair coin 100 times and only getting one head. Now, it's extremely unlikely. So that's the thought process we're going to go through in all of this, is at what point do we begin to say or conclude, does the data begin to tell us or the sample begin to tell us, there's a probability of that happening, but the probability of that happening is so unlikely that I'm going to conclude that there's something wrong with the coin or the dice, or my underlying assumption is not valid. And in a minute we're going to talk about how similar it is to the court system. I'm going to assume the person's innocent, but when you give me all this evidence, the evidence is so overwhelming and so unlikely to happen just by chance that I'm going to vote that the person is guilty. So we're going to break this up into several videos because it's a lot to cover in Chapter 7. We're going to talk about hypothesis testing, and that's going to be the first video or two. Then we're going to understand the risk that we're taking, because there is a risk that, because somebody could flip a coin 100 times and only get one head. So we want to understand what that risk is. We're going to talk about a test statistics, drawing conclusions, the p-value. Then we're going to talk about how you deal with this stuff with proportions. What if we've got more than one sample? What if we have multiple samples? What if we have multiple samples for categorical data and to prove that they're independent? So we're going to go through this, but I want to spend a lot of time on this first theme, hypothesis testing, because it's once you understand that, all of these various distributions and various scenarios, they're all the same. It's the same theme, it's just with different tweaks. So let's talk about the court of law for a minute. And I'm not a legal expert, but to me, hypothesis testing is very similar to the court of law. Just like in a court of law, you assume a person is innocent. When we do hypothesis testing, we assume that the null hypothesis or the status quo is true, and we have to prove that it's not true. So we're either going to reject the null hypothesis, which is the same as finding a person guilty, or we're going to fail to reject the null hypothesis. We're going to say he or she was not proven guilty. We never prove they're innocent, just like we haven't proved the null hypothesis is true. We just didn't have enough evidence to reject the null hypothesis. So, for example, the null hypothesis in my flipping of the coin case might be that the coin, there's the average on 100 flips is 50 heads. If I flipped it and got 48 heads, I probably don't have enough evidence to reject that assumption that I have a fair coin. or that there's a 50% chance of getting a head. If I flip the coin and only 100 times and only get one head, now I probably have enough evidence to reject the null hypothesis, and it's much more likely for us to conclude that the coin is unfair than to conclude that the astronomical probability of getting only one head when I flip it 100 times is what happened. So what is the procedure? Well, again, it's very similar to the court. So the first step is to say, what are we trying to prove? What parameters of a population? Is it the mean? Is it the... What are we trying to prove? In other words, in a court of law, what are the charges? Second step is to say, how sure do we want to be? How much reasonable doubt do we want to be? Normally, people will do significance levels of 99% or 95%, and we'll go through those. Then once we determine that, step 3 is to say, well, what does the data or the evidence indicate? What does the data tell us? Normally in statistics, it's a sample. We take a sample. Normally in court of law, it's the evidence. Then step 4 is to determine, is that data or that evidence compelling enough? Is it, does it compel us beyond reasonable doubt or beyond our confidence level that we should reject the null hypothesis or we should find the person guilty? And then step 5 is, does this evidence overcome? So we'll compare the reasonable doubt. And step 6 is, what do we conclude, or what do we determine the verdict to be? And it's normally we either accept the null hypothesis or we reject it. So that's kind of in the legal or in the simple terms. The steps a little more in statistical terms is step 1. We identify the population parameter of interest and formulate a null hypothesis. The null hypothesis is normally the current state. Once we have the null hypothesis, we also determine what the alternative hypothesis is. Step 2, we select a significant level or a confidence level. How sure do we want to be? How much reasonable doubt are we willing to accept? Step 3, we collect data and calculate what's called a test statistic. The test statistic basically tells us how normal or abnormal is our sample, assuming that the null hypothesis is true. So assuming that a coin is fair and you'd get 50 heads on 100 flips, if we do a data and we get 48, how unusual is that? Or how normal is that to be? Step 4, we determine what the critical value is. A critical value is just takes our significance level and says, you know, if you want to be that confident, then you should have at least so many heads when you flip it 100 times. Step 5, we just compare our test statistic to our critical value. If it's outside the range, we reject the null hypothesis. If it's within the range, then we accept the null hypothesis. Step 6, we interpret the results. What is it? What are we going to conclude? The person's guilty, the person's innocent, the coin is fair, the coin isn't fair. Now, many students think, well, this gets really complicated quick, because if you've read through the chapter, you can see there's lots of examples, and we go through all the examples in the other videos on Excel. But the reason it's getting complicated, I don't view it as all that complicated, because basically it's all these same steps under various scenarios. So the various scenarios might be, you might be comparing a sample to a population. You might know things about the population. You might know the standard deviation. You might not. For every scenario, there's a little different tweaks. You use, oftentimes it's a different distribution. It might be a slightly different formula, but it's all the same theme. Another scenario might be that we'll go through, you might not be comparing to a population. You might be comparing two samples to each other. You might be working with categorical or proportional data rather than numerical data. We might be working with multiple samples, right? And that will bring ANOVA into the mix. Different tools that we'll use if we've got multiple samples. We might be using multiple samples with categorical data, and we'll have to test, do a chi-squared test for dependence or independence. The good news is, in my view, is A, it's all the same theme throughout once you get it. And B, the applications are just enormous. So let me just talk a little bit about some of these business applications, right? If I understand the brand preferences, and there's an example of this that we'll go through in Excel. If I understand the brand preferences and the brand sentiments, it's tremendous impact to my business. If I can statistically predictive my maintenance so that I have less downtime, it's tremendous. If I can figure out statistically how to optimize my network, it lowers my costs, my threats for security or for fraud detection. Is this unusual or is it not unusual? The ability to track assets, personalize the care, all of this stuff, underlining all of this is understanding the data and understanding the statistics around it. So the next video we'll go through each one of these steps. And if there's any questions, let me know.